Hi guys. In our first video today, we were given a polynomial and we were asked to find the zeros. In this second video, I'm going to give you the zeros and your job will be to figure out what was the original polynomial. So we're working backwards. Here's our first example. So it says, what is a cubic polynomial function? Cubic means that my exponent should be a 3 when I'm done. In standard form, so they want it to be all multiplied out. And it says that it definitely has the zeros of -2, +2, and 3. So they're giving us the answers, and then our job is to figure out the original problem. So we need to remember from the first video that the zeros are what x is equal to. It's the x-intercepts. And one thing that we pointed out in the first video was that whatever your x-intercept was, when it was in the parentheses, like the factored form of it, it was the opposite sign. So if my x-intercept is -2, the factored form is going to be x plus 2. And if my x-intercept is +2, the factored form will be x minus 2. And then finally, if my x-intercept is +3, the factored form would be x minus 3. So initially, this question had 3 parentheses with binomials. One had a +2, a -2, and a -3. Again, the opposite sign of whatever the actual answer is. Now, this is the factored version of my polynomial, but they want the standard form, so we will need to multiply this out. This is what we were learning in yesterday's second video about using the box method. I mentioned yesterday that you can only multiply 2 parentheses at a time, so it is important that we only take 2 of these. I'm going to take the first 2, x plus 2 and x minus 2. Now we can use the box to multiply this out. Or, if you remember from last semester, this is the difference of squares. So if you've memorized your difference of squares, you could jump straight to the answer, which is x squared minus 4. After you've multiplied the first 2 parentheses together, you're going to take the answer from that problem, and you're going to multiply it by the parentheses that you haven't used yet, which is the x minus 3. Now, this is not a special case, so we are going to have to actually multiply it out. I, again, prefer the box, so I'll be using the box method. Now, in this scenario, we do not have like terms on the diagonal because we have an x squared in our first parentheses and just an x in the second. So it's not going to have any like terms. You can just kind of snake around. And this is my standard form for my final answer. Let's try one that's a little bit trickier. Okay, so in this problem, I'm going to have a quartic polynomial. That means that in my final answer, the exponent should be the number 4. I also know that because if I look at my answers, there's 4 of them. So that's why it's a quartic polynomial. Remember that you're going to take the original answers, the zeros that they gave you, and when you put them with the letter x, you're going to change the signs. So those -2's become +2's. The +2 and the +3 become a -2 and a -3. And we put them all next to each other. Now this is the factored version. It's not the standard form version. So I will need to multiply these together. Again, you can take 2 at a time. You can multiply them using the box. And we can take those last 2 also and multiply those last 2 using the box as well. So when you're multiplying using the box, you can only have 2 parentheses at a time. So now I've multiplied my first 2 parentheses and created a new polynomial. And I've multiplied my second 2 parentheses and created a new polynomial. Next, I'm going to take those 2 polynomials and I'm going to multiply those together. Now these are both trinomials, so I'm going to make a 3 by 3 box for this one. Now again, on the 3 by 3 box, just like on the 2 by 2 box, all of your like terms will end up happening on the diagonals. So it's really great because look, there's going to be like 9 terms when we're done multiplying this out. It's a lot of numbers. If we don't use the box method, sometimes we forget to multiply some things together and we might accidentally get like 8 or 7 terms instead of all 9 of them. And if you don't use the box method and you're multiplying it all out, you're going to get a really long string of terms. And you're going to have to really search to find which ones are the like terms. Using the box method, we're guaranteed to remember to get all 9 terms, and it's very easy to find our like terms because they're on the diagonal. Again, we're going to start in the top left corner with the x to the 4th, and we're going to kind of snake around, and we're adding. And so my final answer for this one is x to the 4th minus x to the 3rd minus 10x squared. The minus 10x squared was gotten from adding all 3 of these together, right? So 4 plus 6 is 10, and 10 minus 20 is -10. plus 4x, and then plus 24. So this is my standard form quartic polynomial, whose answers are -2, -2, +2, and +3. One more really quick one, just to talk very fast about what we should do if one of the answers is the number 0, because we haven't really done that yet. So if they tell you in the original problem that one of your zeros is 0, that just means that you had a GCF of the letter x. So these positive 5s turn into x minus 5s, and the x equals 0, it's just going to stay a letter x. We're going to put that out in front. Now, my recommendation to you is to deal with that GCF very last. So I would take your two binomials and I would multiply those out first. You can use a box method, you can do FOIL, double distributing, whatever your teacher taught you. I'm partial to the box method. Or this is a special case. This is a perfect square trinomial. So like I can just do this without using any of those other methods. I get x squared minus 10x plus 25. But I would wait till the very, very end to deal with your GCF. So after you've multiplied together everything else, then whatever your answer is, take the x and distribute it to everything. This basically is just going to bump everything up by one exponent on your letter x's. And then this is going to be my final answer. So wait till the end to distribute that x. It's just less confusing that way. This concludes our last video for today.